Hey guys, I wanted to take a second and just make a quick video summarizing what I hope that you got from the POGIL over Coulombic attraction. So everything that we cover this unit is how things are arranged on the periodic table, and then the trends and the patterns that happen across a period or down a group because of that. And the reason for all of these boils down to this thing called Coulombic attraction. Okay, so there's this big formula that you will not have to use. You are not plugging numbers into this formula this year. AP Chem maybe. But the formula is force equals this proportionality constant K. I don't even fully understand where you get this constant, but it's there. Times the product of these two Q's, and these Q's represent the charges, okay, over R squared, which is obviously distance. Okay, this formula basically means that the more charged particles you have, so the product of all your charged particles, the stronger your force of attraction or repulsion. We'll talk about that in a minute. And then the closer they are, the stronger. So it's an indirect relationship, those two things. So real quick, your charges can be, let's write this down in case you're wanting to take notes on this. Your charges, that's your Q1 times Q2, if those are the same charge. Okay, so if you're talking about two electrons with two negative charges, obviously that is repulsion. That means you're talking about how strongly these two things repel each other. Okay, so that's if you are talking about protons and protons, or electrons and electrons. Okay, and these two similarly charged particles, these electrons and electrons, is the reason for how electrons fill your atoms, like why we did all of those electron configurations in Unit 4. Okay, so they fill the orbitals and the sublevels and the energy levels to maximize their distance from each other. They don't want to be near each other. And we'll talk about it more in another unit as well when we do covalent bonding. It's a fun unit. Okay, now if your charges Q1 and Q2 are opposite charges, you get attraction, just like a magnet, right? North and south are attracted to each other. In an atom, a positive and a negative, proton and electron, are attracted to each other. Okay, so obviously this means we're talking about a proton and an electron. Okay, so distance, that's that R squared. The force, that's the F up there in the formula, of attraction or repulsion will increase as particles get closer together and decrease as they spread apart. Okay, so that's talking about distance. The closer they are, the stronger their attraction. The further they are, kind of the less attraction they have for each other. Okay, and again, this all boils down to why we even looked at electron configuration, okay? Because it kind of preps your brain for that. That's why Hund's rule, they fill those orbitals one at a time, because they don't want to be near each other. And then Pauli exclusion, the only time that you can force them to be together in a pair is if they at least have opposite spins. Okay, so the last thing that I want to talk about really fast is just putting this into a picture. Okay, so let's take sodium, aluminum, and chlorine. Okay, let me pull this up a little bit. Sodium, aluminum, and chlorine. These are all elements on period 3, right? Sodium is in group 1, aluminum is in group 13, and chlorine is over there in the halogens. He's group 17. Okay, sodium, oh my goodness, my life. Do a cartwheel for those to come back on. Okay, so they're all on period 3, so they all have how many energy levels? 3, and I'm going to be really careful and try to draw my circles good. Okay, so there's 3 energy levels around sodium, 3 energy levels around aluminum, and 3 energy levels around chlorine. I was about to draw 4. That's going to get on my nerves. I'm going to wipe that out. Maybe that's just the edge of another atom, like butting up against him. Okay, so these should be all about the same size, right? Because they all have 3 energy levels. But let's talk about that in terms of Coulombic attraction. Okay, when you throw in the fact that your protons and electrons are going to attract each other, but your other electrons are going to be repelling, and then the distance. So let's talk. So sodium, his atomic number is 11, aluminum is 13, and chlorine is 17. Okay, so sodium has 11 protons. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 11 electrons. Okay, so on energy level 1, you can only have 2 electrons, right? Because you only have that S block. Energy level 2, you have S and P, so you can have 8. They fill one at a time. They don't want to be near each other. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 10 electrons. So sodium has 1 valence electron. And he's in group 1. He's an alkali metal. Okay, aluminum has 13 protons. So 13 electrons. 2 on energy level 1. 8 on the second energy level because you have S and P. 2, 3, 4, 5, 6, 7, 8. So that's 10. So now he has 3 valence electrons. Okay, and chlorine, our friend with 17 protons, I think that's 17, and 17 electrons. He has 7 valence electrons. Okay, so they're all about the same size, right? So technically you would think they would have the same Coulombic attraction. But what are you adding in each of these nuclei that's going to affect the force of attraction between the protons and the neutrons? This, you have 11 positive particles, 13 positive particles, and 17 positive particles. So you have more charged particles in chlorine, which means you have a greater Coulombic attraction. Okay, so even though they're all the same size, chlorine has the greatest Coulombic attraction because he's got the most protons in his nucleus. When you add protons to your nucleus, I always tell my kids, you're adding strength to that nucleus. So he's pulling on these outer energy levels with more strength. So technically, they should be the same size because they have 3 energy levels, but the strength of this nucleus is going to be pulling with a stronger force of attraction on those energy levels. Okay, so chlorine, even though he has 3 energy levels, is actually a little bit smaller than sodium. Okay, that's your first periodic trend. that you're going to be learning about on Monday. So that's a trend for atomic radius. If you've already looked through the PowerPoint, you recognize that. And every single trend on the periodic table is directly related to and can be explained by Coulombic attraction. Okay, and you are expected to be able to explain them via Coulombic attraction. Okay, so you're going to mostly talk about the strength of the nucleus, the number of protons, and I'm going to give you a name for that in just a second, or the distance of those outside energy levels. Okay, so on this one where they have the same distance, it's the charge of those protons in the nucleus. Okay, there's one more term that I want to tell you, and it's more a vocabulary term, like you understand it now, but I will say it a lot, and you'll hear it in AP Chem a lot, and you'll hear it in regular Chem or pre-AP Chem a lot. It is called effective nuclear charge. Okay, and to summarize it, before I write down the actual definition for you, it's just how strong is your nucleus? How effective are the positive charges in your nucleus? Okay, so the more protons you have, usually the stronger your effective nuclear charge. Okay, so the definition, and the symbol for that is ZEFF. Okay, effective nuclear charge. So basically, the more positive the nucleus, the greater the attraction for its electron cloud. Okay, that's effective nuclear charge. So a lot of times, although I want you to talk about your trends starting next week in terms of Coulombic attraction, you can sometimes throw in effective nuclear charge. Right? The more positive your nucleus is, the more protons you have in your nucleus, the stronger your effective nuclear charge. Okay, and there's these things, you don't really have to know this, but in your electron cloud, there's this other thing called shielding. Why did I draw 4 energy levels on something that only has 5 protons? I don't know. But remember, they always are there. So I'm just testing you, making sure you remember that. So if you have protons that aren't valence electrons, so on this one you have 5 electrons because you had 5 protons. The outermost electrons are your valence electrons, and the ones on the inside are called core electrons. Okay, so you already know the term valence electrons. Your core electrons are all your other electrons. And those, remember, because they're the same charge, they repel those valence electrons. So you have a lot of stuff going on with nuclear charge and these core electrons. But remember, it all boils down to Coulombic attraction. That is a great way to just summarize everything when you're trying to give a reason. There's going to be a big push this unit for you guys to do a lot of free response type questions when we introduce the trends, which will happen on Monday, to be able to not only tell the trend and what happens as it goes across a period or down a group, but to explain it with Coulombic attraction. That's going to be a huge part of AP Chem and the AP test. So we'll be pushing you to do the same. All right, guys, hopefully the POGL helped. Hopefully this helped. On Monday, we'll do another recap if we need to, and then we'll start actual trends. We will be doing 4 trends in here. Atomic radius, an ionic radius. Radius is how big. Electronegativity, you don't know what that is, and ionization energy, you don't know what that is. So we've got some vocab to talk about Monday, and then we'll get into the trends. All right, guys, hope you have a good weekend.